Two boys are standing near the ends of 100-meter long conveyor belt that is running with a constant velocity of 1 meter per second. The boys step on the conveyor belt and its opposite side start walking towards each other. After meeting, they immediately return towards the ends of the belt and then continue the process repeatedly. The boys walk with a constant speed of 3 meters per second relative to the conveyor belt. What distance relative to the ground do the boys walk in first 300 seconds? So a wrong method. So if this is the conveyor, boy 1 will be here, boy 2 will be here, and since with respect to conveyor, or let's say with respect to the belt, always 3 meters per second. That is left or right, that we don't care right now. 3 meters per second, 3 meters per second. So they'll first meet at t is equal to v relative. So between the boys, this will be some 50 meters, this will be some 50 meters. So they'll have t is equal to 50 by 3. So they'll meet the correct time. So then after that, they should start going in the other direction with speed 3 meters per second and speed 3 meters per second. They'll reach at t is equal to 50 by 3 plus 50 by 3 because they were here at t equal to 50 by 3. So the graph will come out to be for boy 1 velocity with respect to belt. Like this. So from here we can tell that velocity of boy with respect to ground is velocity of boy with respect to belt is velocity of belt with respect to ground. So this will become 1 meter per second plus 1 meter per second. So then I can just add 1 everywhere. 4 meter per second minus 2 meter per second. So graph keeps going like this. So this is one cycle. One cycle will correspond to 100 by 3 seconds. This will be 50 by 3. So this will be 200 by 3. This will be 100 by 3. Therefore, in 100 by 3 seconds, 100 meters, which implies in 300 seconds, 900 meters. But why this is wrong? That is because, see, the v relative with respect to belt is like with respect to any particle that has been glued to the elevate to the belt. So that means that if this is how the belt is rotating, if you have some guy over here, let's say he sits down, he is the one who's watching these two boys. He will watch this boy, he'll watch this boy, and then he'll make the observations. But the problem is that with respect to this guy, right, With respect to this guy, the boys don't reach 50 meters and then they won't stop. Since this guy is always moving like this, with respect to him, if you look, the ends, this will be the ends, right? Let's say, in order for the boys to know that this is the end, let's assume that the person who has set this up has kept a rod over here. So if you look with respect to him, the ends will also move. This will seem to come closer. This will seem to go away. So since with respect to this guy, if you look, the ends are itself not the same point. Definitely these boys will, for him it will not look like they come meet in the middle and then go away. Instead, for him it will look like something they'll come and will meet here, and then the ends will go somewhere, and then these boys will go somewhere. So this is the problem if you do this method. The assumption is basically wrong. So correct way is kind of like raw method, but we have to apply that. T equal to 0. Since this guy, let's say he's going with 4 meters per second, this guy will go with 2 meters per second at t equal to 100 by 6, which is 50 by 3. They meet. So t equal to 50 by 3. What will happen is, see, right now the points that I am fixing is the rod that will be here, right? I am assuming that this point is fixed now, and that is a fair assumption. But in this case, when we looked with respect to this guy, this rod, right? This rod or this rod, any of the endpoints, the exact place of the endpoints was not fixed when you looked with respect to this guy. When you looked with respect to him, these endpoints were not fixed. That was a problem. But now, since we are solving with respect to ground, the endpoints are fixed. So t equal to 50 by 3. He would have covered some 200 by 3 meters. He would have covered some 100 by 3 meters. Now this guy, let's say he moves with 4 meters per second. This guy moves with 2 meters per second. So clearly t equals 50 by 3 plus 100 by 3 by 4. The duration is between these two gap is, I'll give 100 by 3 by 4 seconds. This guy would have reached this end point, and now he'll turn like this and he'll say I'll go like this 2 meters per second. This guy would have gone 2 into 100 by 3, 100 by 3 by 4. He would have got 100 by 6 meters. So 200 by 3, this will be 400 by 6, 100 by 6, 300 by 6, so 50 meters. We will be at 50 meters. And is still walking at 2 meter per second. Now after t is equal to 50 by 3 plus 100 by 3 by 4 plus another what is it is 50 is 25 seconds, right? After 25 seconds this guy would have reached his end. Now he can start going with 4 meter per second, whereas this guy now he is here 2 meter per second. He would have traveled 50 meters. Now where will they clash? They will clash at t equals 50 by 3 plus 100 by 2 by 4 plus 25 plus they will clash at 50 by 6. They will clash here. This guy would have traveled how much? 50 by, the gap is 50 by 6 between these two. 50 by 6 and 50 by 6 into 4, 100 by 3. So he would have traveled 100 by 3. And he will be here. He will move 4 meter per second. He will move 2 meter per second. This will be 200 by 3. Now we can go for t is equal to 50 by 3 plus 100 by 2 by 4. Wait, sorry, 100 by 2 by 4 is how? So it was supposed to be 100 by 3 by 4, or also 100 by 3 by 4 plus 25 seconds plus 50 by 6 is 100 by 3 by 2. So here we can see that both of these guys, to reach their respective endpoints, they will take 100 by 3 by 2 seconds to reach their endpoints. This will come out to be, at this time they will be looking at this. So they have reached their endpoints, and this will come out to 50 by 3 plus 50 by 6 plus 50 by 6 plus 50 by 3 plus 25. It will come out to be 75 seconds. So the time period, clearly after every 75 seconds the same thing will happen. And now let's go ahead and calculate the distance traveled by the left side boy. Distance traveled by left side boy will come out to be first 200 by 3 then plus 50 and next another 100 by 3 then another 100 by 3. This will imply 150 100 by 3 meters. So 300 oh wait, that's a mistake I think. Let's see the velocity versus time graph first. That is easier to, because your calculation mistakes might happen. Velocity versus time. For 50 by 3 seconds, 50 by 3 seconds, 4 meter per second, 200 by 3. Next, for the next 100 by 3 by 4 seconds. 3 by 4 seconds. Next 100 by 3 by 4 seconds. He has traveled with 2 meter per second. This corresponds to 150 by 3 meters. And then again for another 25 seconds he traveled to 2 meter per second. This is a 25 seconds. That comes out to be 50 meters. Then for next 50 by 6 seconds he travels 4 meter per second. That comes out to be 100 by 3 meters. And finally for a final of 100 by 3 by 2 meters, so 100 by 3 by 2 seconds, he travels with a speed of 2 meter per second. 100 by 3 meters. So if you add it all up, you get 100 plus 150 by 3 plus 50. This comes out to be 150 plus 50, which is equal to 200 meters every 75 second cycle. And also clearly from symmetry we can show that, see, at this point, this case and this case, right, they are almost the same. See, 2 steps, another 2 steps event, but normal thing. But what I mean is, due to symmetry we can definitely see that this guy and this guy, they have some symmetrical path, some kind of symmetry in this step and this step. If you look at it, it seems very much symmetrical. So therefore 300 seconds is equal to 8 times 75 seconds, which is equal to 8 into 4 into, so 4 into 200 meters, which is equal to 800 meters, and that is answer.